Namaskar. I'm Gopal Dhawan, a geologist by training. Professionally, I was working in NHPC and Mineral Exploration Corporation for investigation of several types of infrastructure projects in, in our country and Nepal, Bhutan, and Myanmar. I'm thankful to India Construction Week 2020 for inviting me to share my views during this important conclave on reviving construction industry in post-COVID world. I am sure you will agree that tunnels are very important and integral part of any infrastructure project. Recently, the famous Atal Tunnel has been completed at the highest altitude in Himalayas, and it has been recently dedicated to the nation by our Honorable Prime Minister. Several other tunnels are also under construction, and more tunnels are under investigations and planning. But construction of tunnels in Himalayas is not easy because of inherent geological problems. I would like to share my views with you through a small presentation. Please allow me to share my screen with you. Well, here it is. So through this presentation on understanding investigations for tunnels in Himalayas, I will proceed towards a direction which will ensure speedier construction of tunnels with less problems and less geological surprises. Although tunneling technology has improved significantly in other countries, but in India, rate of tunnel excavation is not more than 60 meters per month per phase. And even deployment of tunnel boring machines have not helped in completing tunneling projects on time. Case studies of Parvati 2 and Tapovan Vishnughat projects are already known to everybody. Here we are still stuck due to unknown ground. Conventional investigations have provided very limited understanding of the ground. So therefore, we need to investigate tunnel alignments in a better manner with a backup of modern investigative techniques. I will discuss with you strategy of investigations which will reduce percentage of unknowns along the tunnel route. Any tunnel can be divided into three segments. Some portions of the tunnels are well known. You know the geology, you know the type of problems which will come, you know where they will come. So we call those areas as known areas. Then the second type of area is known unknowns. We know the type of problems, but we really do not know where it will come. And the third category is more dangerous. Unknowns. We neither know what is unknown, we nor know that where this unknown is going to occur. And these are the areas which pose difficulties, problems, and often these are known as geological areas where we encounter geological surprises. With little modification in our approach, and which I call strategic approach of investigation, we can increase known areas, and the other two areas will reduce significantly. And therefore, I say that strategically planned investigations will convert gray areas to known knowns to a great extent. And why these unknowns are there along a tunnel route? This picture conveys it all. It is from Bhutan Himalayas. The red line signifies a proposed tunnel alignment. This is the name of the project is Chamkarcho project. It's a hydropower project. You can appreciate the inaccessibility, complexity of geological structures. There is practically no outcrop visible. Outcrop means the areas where you can see geology. And in this kind of terrain, you can't send your truck-mounted drill machines for deeper level of understanding of the ground through drilling. So therefore, unknowns are bound to be present along a tunnel route. But up to what extent? That is to be deliberated. So after doing all our conventional geological explorations, we try to produce a geological section along the tunnel alignment. It looks something like this, and various types of rocks which are going to be intercepted during excavation of tunnel are shown with different symbols and different colors. But this is a very symptomatic. This is a very approximate kind of assessment of the geology along the tunnel route. Finally, based on this data, we try to provide inputs to designers in form of rock mass classes. So from geological classification to engineering classification, but the data almost remains the same. So in case our data is based only on surface geological mapping, there will be more uncertainties. And this needs to be improved by good quality investigations with a backup of drilling, geophysical surveys, and modern techniques. And if we do good investigations, there will be less uncertainties, and there will be less cost and time overruns, and there will be less claims also. Why do we do investigations? Firstly, to develop a good geological model. If the geological model is reliable, the tunnel layout will also be optimized. And then we will be in a position to infer rock mass conditions along the tunnel route properly. If we can do that, we will be in a position to forecast geological problems during tunneling. And finally, we will be in a position to design the support requirements and estimate cost and time required for completion of tunnel. Normally, you must have heard that investigations are not adequate. So when you are going to say that investigation is adequate, this I will try to explain you with help of these two curves. The brown curve, you can follow my cursor, signifies that with more investigations, more investment, we acquire more geological and geotechnical information. So as our level of investigation improves, we spend more time and more money, we acquire better level of understanding of the ground. But you will see that beyond 60%, the curve rises sharply, and this becomes almost subparallel to the vertical axis. It means that no matter how much more money you are investing, the level of information is not going to improve. So, in other words, this is the practical limit of data acquisition. On the other hand, this blue curve signifies the risk. As we gather more geological and geotechnical information, the level of risk reduces. Both these curves intersect at a point which is indicated by 60% data acquisition level. This is the optimum level of expenditure and information collected. In other words, beyond 60%, it is difficult or impractical to collect information about the ground during the investigation phase. You can further have a look on this diagram where you will find that during the feasibility stage, we invest about 10% of time and 10% of money, and we get 30% knowledge of the ground. In the next phase, which is preliminary design phase, we add to our knowledge by 20% by investing 20% more time and money. In the third phase, which is the detailed design phase, we invest 30% more efforts for only 10% gains. And this is this 60% optimum level beyond which the remaining information is collected and used only during the construction stage. So the 40% information is to be collected and utilized during the construction stage. It means that we have to provide certain instruments in our contractual architecture to attend to this type of situations. We need to inbuild scope of certain specialized investigations during the construction stage. Only then we can attend to these problems. Now, what are the methods of investigations available to us? As I said, our conventional method of investigation is geological mapping and then recording geotechnical parameters. In some unknown areas, we need to do exploratory drifting. It means making small horizontal openings within the hill, then doing some short holes, geophysical techniques, and rock mass properties testing or rock mechanic testing. There's less time, but I would certainly indicate that with application of LiDAR-based mapping, airborne geophysical surveys, directional drilling, which can go very deep and which can go along the tunnel also, and tunnel seismic prediction system during construction. Simultaneously with construction of tunnel, we can improve upon the level of geological data. We have some other tools available to us, which are known as engineering classification of rock masses. There are two most widely used classification systems in vogue. In India also these are used, the RMR system and Q system. These were originally designed to estimate the tunnel supports, but nowadays these are improved to a level that we can estimate realistic rock mass parameters from these systems. And these are very useful during the construction for quantifying the rock mass conditions and select the appropriate support class. We can resolve contractual disputes and arbitration problems, and due to the design changes. RMR and Q are found to be equally effective for very poor to very good rock masses. Before the tunnel construction starts, it is necessary to identify geological and hydrological risks. The most commonly occurring risks in the Himalayan tunnels are that tunnel may run into deep overburden. There may be an unexpected fault zone, squeezing rock or rock burst. There may be some weak zones or fractured rock masses. There may be variation in the predicted rock classes or rock types affecting the completion schedule. This is the most commonly occurring risk which we are facing. And then the groundwater problems. All these risks are to be quantified and studied by making a risk matrix. You can have likelihood of the risk on the in the column, and then the consequences of that risk in the row, from insignificant to catastrophic consequence, from rare likelihood to almost certain likelihood. And then these are classified into low risk to extremely high risk, that is R1 to R4. So totally the risk can be divided into 4 classes, and for every class we have to have a strategy for implementation. Finally, as I said, that you can reduce or you can increase the known areas, but you will have to deal with the known unknowns and unknown unknowns, and even thereafter there can be some residual uncertainties. But in case you are able to increase your known unknowns, in case you are able to increase the percentage of known knowns, you can deal with this with good design. Whereas known unknowns can be mitigated by appropriate contractual architecture. And unknown unknowns can be minimized if investigations are embedded in the construction phase. And residual uncertainties will have to be dealt as they will come. So, gentlemen, key to the success for tunneling projects is investigate adequately. In your contracts, leave some scope for mid-course correction. Choose the right kind of agency, the contractor, and prepare a risk management plan for difficult reaches during construction. And we must do quick decision making in tunnels, and that is going to facilitate timely completion of project. Thank you very much. The time was very short, so I had been very brief. Maybe sometimes if I get an opportunity, I can elaborate upon the strategy of total investigations for tunnels. Thank you. Thanks to the organizers.